Someone sent me a video where a flat earther is going to do celestial navigation using flat Earth. Let's have a look.
Hello everyone. In this video, I'm going to be demonstrating celestial navigation on a flat Earth. In this video, I'm going to take some measurements and I'm going to do a fix using the sun.
Now you may be wondering why Satan is narrating this video. Well, Satan has a long and rich history with flat Earth. I've in fact done a video on a guy that claims to be Satan, and he is the flat earther that's been on YouTube the longest.
Projected outwardly to the world that I'm Satan, the Antichrist.
I'll link that in the description, but this is a different guy.
To do my measurements, I use this homemade astrolabe. An astrolabe make me able to measure some angle of elevation to the star. This is a paper that summarizes the measurements I took this morning. As you can see, my first measurement took place at 16 past 11 o'clock.
In case it's a little difficult to understand the voice of Satan there, he's going to measure some angles to the sun using that homemade angelometer. Perfectly fine thing to do. Now, ironically, the name of this channel is Globalist Perspective, and that will become ironic later, but also it's ironic because Flat Earth Satan's Voice is a channel that also has as its name La Savior.
The measured elevation angle is about 49 degrees. As you can see, I didn't make any correction because the scale that I use for my map is way too small. Then I took a second measurement at 24 to 1 o'clock. This time the measured angle of elevation is about 55 degrees. Finally, I took a third measurement at this time at 24 to 2 o'clock. The measuring angle of elevation was about 63 degrees. This is where the 3GP should be. If you wonder where did I get this value for the GP, I got them from a Discord bot from a celestial navigation server that I will put in the description if you're interested.
Yeah, you got the GP of the sun there from a bot on a Discord server. Now that bot on the Discord server uses the position of the Earth and sun in three-dimensional space in the solar system to determine the GP of the sun. But never mind that, Mr. Flat Earther, who's not using the globe. You're using the globe. Anyway, let's continue using the globe to determine where the GP of the sun is and see what happens.
This is the map I used. It's a north-centric pole projection. As you can see, the scale is at the bottom.
Ironically, in this flat Earth celestial navigation demonstration, he has now twice used the globe. This time it's a projection of the globe onto that map. He even used the word projection. Also, ironically, for number 3, he used 5,000 kilometers in that scale. Now, he is a bit off in that measurement, but let's let him go on that a little bit. 5,000 kilometers is supposed to be shown here as the distance between the North Pole and halfway to the equator, making it 10,000 kilometers from the North Pole to the equator. And even though his scale is a bit off, that's fine. We know where that number came from. It's a measurement from the North Pole to the equator using the globe to do that. So there you go. There's the third time that he's used the globe in this flat Earth celestial navigation demonstration.
The calculation is very simple. All you have to do is to subtract your angle from 90 degrees and then multiply the result by 60 nautical miles to get the distance of the GP in nautical mile.
One more time, he used the globe. 60 nautical miles per degree matches the geometry of somebody on the surface of a sphere. It does not match the geometry of a flat Earth with a sun above it at a certain fixed elevation. For that, you would need to use an arctangent computation, some trigonometry, not the simple linear 60 nautical miles per degree. Oh, geez, 4 times.
Then, what I did is that I converted it in kilometer, and I divided this value by my scale. This gave me the radius of my circle of equal altitude. I repeated that for the 3 measurements, and then I plotted it on my map.
So he's done what you really do in celestial navigation. You determine the distance that you are from the GP of the sun or the star by multiplying by 60 nautical miles. Again, that's globe geometry. That gives you a circle of equal altitude. You know that you are somewhere on that circle. When you have one circle, that's all you know. When you have 2 circles, those 2 circles will intersect at 2 locations, and you're at one of those 2 locations. Now, if one of those locations is on land and you're at sea, well, you know that you're at sea and you know which one it is. To be more precise, then you can get a third. And so where those 3 circles intersect is where you are. It removes any confusion of it. So let's see how that works on his globe projection map.
And boom, this is the result I got.
Yeah, he actually said, boom, that's what I got. Like boom, as if he had some like success. But when you do celestial navigation, you look at the spot that the 3 lines intersect. But when we look at the intersection of his 3 lines, the circles, they don't actually intersect. On one end of it, we're looks like we're over on the edge of Russia. On the other edge of it, we're somewhere south of Greenland. This is amazingly wrong. It's a huge variation in where you might be.
So my answer is 48 degrees 51 north and 1 degrees 9 west. So the actual answer is at the top, and between my answer and the actual answer, I got a 284 nautical mile difference. This is actually not bad for a small scale in a map like this.
284 nautical miles off. He says that's not bad, but it is horrendously awful. Imagine being at sea and doing celestial navigation and being 200 and whatever, that far off. Holy cow. There is no way that any celestial navigator would survive the trip. They'd get chucked overboard.
I actually got a nice fix. I will certainly use some of the projection with a bigger scale in order to get a more precise fix. And anyway, this is for all the globers who think celestial navigation could be achieved on a flat plane. You got proven wrong.
So yeah, that's not very good at all. And you didn't use flat Earth, you used the globe 4 times, so you're going to have to do better than that. But let me see your globe-based flat Earth celestial navigation doing my challenge, which is on screen right here. Show how it's done and see if you can get the position fix using those 3 stars. Now, I have a challenge, a celestial navigation challenge. It's on pause right now, but if you want, Mr. Flat Earth Satan, voice of Satan, if you want, I will reissue my challenge and I will put $10,000 in escrow. We can decide together on who will hold that escrow money. And I'll follow the same rules. I'll link them in the description. You just need to provide the method, which you've done here already, and then run the celestial navigation 2 different times for 2 different fixes. Anyway, email me, La Savior, at mctune@mctune.net if you want to give it a shot. It will be absolutely hilarious watching you try to do it. To use, of course, you're going to use the globe. Again, you have to use the globe because that's what flat earthers do. Anyway, it's the first law of Flurf. If you enjoyed this and want to see if there might be a follow-up to this, make sure to subscribe so that you can see when it comes around.